Guys, today we are going to be doing this problem. This is chapter 15 of AP Chem, and the name of it is called Acid-Base Equilibria. Ignore my handwriting. Okay, let's just get straight into it. So the first thing it says is to calculate the pH, and the formula for pH is equal to negative log of the concentration of your proton, which means that we are solving for H+, which sort of gives you an idea of how to start. So pH of a 0.1 molar propanoic acid solution. So here's my propanoic acid, and it gives me my Ka. That is your biggest hint that you will need to set up that equilibrium expression, right? X, Y, let's just say Z, even though it should be inverse, but you know. Okay, so let's start by writing the equation. So they're telling me propanoic acid solution, so that's HC3H5O2, and I'm solving for H+, which means that this definitely has to disassociate, right? Because it cannot, you can add water and you can form hydronium, but it wouldn't make sense to do that because you can just simply disassociate. And plus the conjugate base of this acid, O2, so this is your acid, this is your conjugate acid, this is your conjugate base. This is what's left after a proton is accepted, and this is what's left after a proton has donated. Okay, so now I know I need to solve for H+, and it gives me my Ka, which means I'm going to go ahead and set up an equilibrium expression. My Ka is going to equal to my reagents over my products. My first reagent, my H+, multiplied by the concentration of this product. I forgot to put the symbol. All of that actually over the whole acid, right? O2. Now, you can do the ice table here, or you can fill it in your head. You can sort of see, but I'm gonna show you guys the ice table. So we have the initial, the change, and the equilibrium for this expression. So propanoic acid is often abbreviated like this, so I'm just gonna write it to save time. Goes to H plus OPR minus. Okay, so let's start. Our initial concentration of HOPR is given to us 0.1 molar solution, so that's 0.1. Our initial concentration of H plus and OPR, they don't exist. 0, 0. Now, our change in concentration for HOPR is going to be minus X, right? And our change for H plus and OPR is going to be the same, a plus X and a plus X, which means that the equilibrium value of HOPR is the acid is going to be 0.1 minus X. This is just going to be X, and this is just going to be X. And now with these values, you can go ahead and plug them into your Ka and solve. So back to my Ka, which has a value of 1.3 E negative 5, which is equal to which is equal to the concentration on the bottom, 1, we said that was 0.1 minus X, comes straight from here, times X times X, which is equal to X squared, which now says that, so based off the 5% rule, I can neglect the value in the change in X and say that X is much less than 0.1, so whatever X is, it won't have an effect on my value, so I can just say now that 0.1 over X squared equals 1.3 E negative 5, and now I solve for X. So I'm going to multiply this to get rid of the denominator, and I'm multiplying by 0.1, so I know that it's just going to move up from 1.3 E negative 5 move down to E negative 6 equals X squared. And now you have to take the square root of both sides to solve for X. And once you take the square root of both sides, you get that X equals 1.1 E negative 3. And X is equal to your concentration of H+, right? They are directly proportional, and it also says it right here. So now you have to solve for the pH, and now this is the easy part. You take this value and you plug it into the formula. pH equals negative log of H+, or in this case, X. So pH equals the negative log of 1.1 E negative 3. When you type that into a calculator, you should get a pH of 2.96. And also for this assumption right here, you're supposed to check it, but I just knew that it would pass. But basically what you do is you take x when you find out, so 1.1 e negative 3, and you divide by the initial concentration, which we have 0.1, and if it's less than 5, then it passes the rule, and you don't have to use the quadratic formula. 1.1 e negative 3 divided by 0.1, that gives you and then, sorry, you have to multiply by 100. Times 100 gives you 1.1, which is less than 5, so it passes the rule.